Okay, let's go ahead and get started. Well, hello everyone. Thank you so much for joining us for today's session. We're actually going to go through a few cool topics in the NX, including NX layout, realizing shape, convergent modeling. My name is Elise Woods, and I'm one of the marketing specialists here at Swoosh Technologies, and I will be your host today. Just a little bit on Swoosh. We're actually an award-winning PLM software provider and partner of Siemens PLM. Our team has been dedicated in providing you the best software solutions, technical service support, and process-based training to help you optimize your design and manufacturing processes. Our commitment to changing the way designers and manufacturers learn and leverage PLM tools has been a major focus for us over the 11 years and will continue to be our goal going forward. Today, our presenter is application engineer Garrett Koch. He's a well-accomplished in design, drafting, and engineering in a variety of industries since 1973. Garrett has been developing patented designs and has taken on large-scale engineering projects. In 1994, he began his career in CAD training, coursework, development, and technical support. He is a certified NX professional and is an expert in NX installation, conversion, and technical support. Today, we will be covering NX from 2D to 3D. Every product begins with a concept design. NX gives the designer critical tools when it comes to creating and modifying shapes, layouts, and scan modules. Garrett will be presenting some of the best features that NX has to offer, from layout to realizing shape to convergent modeling. If you have any questions, please feel free to add these into the questions box located in your GoToWebinar panel. Garrett will have your questions answered during the Q&A portion taking place right after the presentation. All right, Garrett, go ahead and take it away.
Thanks, Elise. It's good to be with all of you today. We are ranging all across the country, from Texas to Minnesota and New York to California. That pretty much takes care of the contiguous states. We here at Swoosh are located kind of in the heart of the country, just a little bit west of St. Louis, Missouri. Now, we're going to get into some meaty topics today. NX layout, realized shape, and the newcomer of the three, convergent modeling. Before we discuss these, though, because they generally are designed with an intent to address conceptual design, we need to just spend a moment or two talking about that very topic, the concept of, well, concept design. As we start looking at conceptual design, Wikipedia has a definition that we can understand with the terminology as being important here. That's a type of art which gives precedence to the hypothetical function, and it's also the creation and exploration of new ideas. And some of those terms are sometimes not considered when we talk about design. It is the first phase of design, and what you will find is it's an essential definition where you have to go through the identifying the requirements of your customer's input, or what it is you're trying to achieve as the objectives of your product. And you need to have basically a mentality that says, explore all possibilities. You want to be creative, you want to be investigative, you want to explore new ideas, and you want to make sure that you're not confining yourself with inside the box thinking. This is going to help you to come out with products that are innovative. You'll be able to leverage your competition, and your sales projection will increase in the demographics because of being able to relate to more and achieving more with your product. Now, the abstract thinking that comes with conceptual design sometimes is a little bit hard to relate to for the mechanical designer, but the conceptual design definitely, it is more abstract than it is technical. In this list, you can see that product design is really a more general terminology that includes concept design, but also actual product styling, if that's part of the product, whether it be a fascia panel inside of a some kind of an operating machine, or whether it just might be a housing on the outside of the product. The product design also includes the engineering and CAD modeling that we're all familiar with, but then also, again, based on necessity, You might need to go through a simulation to check movement, to check stress, to do analysis of perhaps thermal considerations, and validate that it meets the requirements. Then, of course, there are always the documentation requirements, whether they be a standard such as the Department of Defense or Department of Transportation or medical, ISO. That list can go on. Once your documentation allows you now to publicize the design and specifications of your product, now you can all review it together, and then you go into your change and improvement cycles, hopefully only once, finally getting to your release to production. Now, with all the personal experience I've had, I've learned that a good product designer always considers the fabrication process while you're designing your product. If you can't make it, it's not of much use to try and design and market it. However, conceptual design should avoid that limitation and get solutions without those confines until the next phase of the process. As we start looking at this thinking outside the box, it allows us to explore, to capture, to transform your ideas, and really it's kind of an 80-20 rule, where 80% of those ideas of thinking outside the box, yeah, they need to go back into the box, meaning the trash can. They're just not worth it. But that 20%, that's where patents come from. And if you give yourself the freedom to explore those ideas that are outside the box, it can pay off. Rather than doing it the way we've always done it, you need to stop that thinking and be innovative in order to capture more of your market share and get to those customers first. Now, the first of the three topics that we're going to share with you today, NX layout, is a two-dimensional based approach of conceptual design. It's very fast, and you're going to find also that it's familiar with the skills that you already know about NX. Why use 2D? Well, many companies already use 2D, whether it might be in an AutoCAD or some other simple software product. It's just the way that many companies developed their processes, and then that gets passed on to the actual engineering department that then gets into the nitty-gritty of the sizes and the numbers and the locations and the definitions of exact detailed specification. Now, when you're getting involved with this area of the design in the concept side of things, you still need to get some substance to help you understand what you're developing. To just have ideas in your head really doesn't cut it. So to have something you can look at, something you play with, something you can modify, move around, change the shape, add in shapes, combine them, what you're going to find there is that as that gets passed on to the 3D side of things, the benefits are significant. And a lot of times it is just easier to design in 2D. It is the paper napkin concept, just like we've always talked about with sketching. Now here we see kind of a comparison of different situations in our industries today when you've got multiple design systems, some of which address conceptual design versus your 3D product design. When you get into multiple design systems, sometimes one of those tools is inadequate to accommodate the other task. And you can also have a disconnect between those tool sets where one doesn't give you usable data in the other set. As you pass your 2D definition or your conceptual definition onto 3D, does it involve migrations, translations, redefinition, recreation? You can see the impact on all these. Higher cost, longer to productivity or longer to production, sometimes potential risk to the quality. And as you look at just maintaining the multiple systems, your IT, your admin, they go through headaches. You've got X number of systems times, well, every user that you've got in your company in those various departments times every release of those individual software products, and then you multiply that times any of the limitations of your hardware, your operating system that also have to be upgraded and matched properly. It is a pain. It's also a pain for their designer. They have to habitually change, understanding the new interfaces of the new changes. There's new functionalities, new processes have to be incorporated, new workarounds sometimes when a company changes a software. The need for multiple users within a company with different and diversified skill sets, that's also a problem. You get into those job codes where you have more and more different kind of people that can't do the other one's job. And then, of course, there's training that's involved with this whole process as well. It's all part of the overhead. Now, moving on, the traditional CAD modeling that you should already be familiar with, as we would look at NX as an example. You plan your product as an assembly, and as you break down that assembly into the individual parts, you would then start building your assembly with one or two approaches, a top-down approach, a bottom-up approach. The bottom-up being more realistic, where you create the individual parts, then you add them into your assembly, whereas your top-down, you actually build all the models in an assembly file, and then you use that command of create new component to push those models down into the individual part files or sub-assemblies, as the case may be. Now, you're going to see something similar between that and NX layout, and it does the same thing. As once you've defined your NX layout and the 2D components that are a part of that layout, they can be essentially pushed into individual part files, but it's really one single command that tells NX to generate the assembly structure. Now, once you've got your structure, once you've got some of the geometry built into the individual part files, you go on and develop that shape, whether it means primitives or profiles of curves in sketches, constraining, sweeping, Boolean operations, detail features, etc., etc. Now, that's the traditional approach, let's call it. The NX layout approach is, again, something you're probably already familiar with: drafting, a drawing sheet, a drawing view on a drawing, and sketching in that drawing view. You create the curves, normal sketching activity, nothing different, but you're just creating 2D profiles of the parts that are going in your assemblies. As you get to a level of satisfaction with how many of those you've created, or you've created all of the 2D components, then it's a matter of simply clicking on a button to say create assembly or copy to 3D, and it creates that assembly structure automatically for you, meaning individual part files are created that are all .prt files that contain the geometry of those 2D components that you defined. Additionally, your 2D components get saved in a library for reuse even in the layout that you're currently working on. As soon as you define the 2D component, you can then add it into multiple places, multiple positions, orientations, whatever you might need. Now, where did NX layout come from? Just in a word, or a quick bit of history here. In the old days of Unigraphics, you had solids that came out in the late to mid-'80s maybe, and one version of it was parametric and another wasn't. But the bottom line still was when you needed to come back and edit, a lot of it was face editing. Well, that got developed a little bit later into a package that they called direct modeling. And then direct modeling was then enhanced in NX6, and they came out with synchronous modeling. Synchronous gives you a lot more capability of editing on the fly without having to completely understand the entire history tree. And then from synchronous modeling, pushing that into the 2D world, we then gained the functionality of synchronous 2D. That, in essence, is the parent functionality of NX layout. Now, let me ask you a question. When you are doing your work with NX, do you use the assembly's efficiencies? Do you use template files? As you need to create an assembly to contain the part that you're working on, do you actually create a new part file and then add that component in, or do you use that one little button, create new parent? There are many commands, many efficiencies that NX layout accommodates for you very easily, very quickly. Now, NX layout is fully integrated, meaning that what you create in the NX layout is totally usable, and really it isn't really any different than what you would create in sketches, or if you're doing synchronous 2D activity, as you create constraints in the sketches, nothing else is different there. And it's just common functionality, so really there's not much of a learning curve. Understanding that despite NX layout being a portion of drafting functionality, it is not drafting. It is modeling and assemblies in a drafting environment. That's a pretty novel concept, but not hard to learn. It's a neutral format. It means legacy data is ready to use. If you've got AutoCAD, DXF, DWG, maybe any other CAD system that maybe bring in CGM curve definition, that can be added into your NX layout. It can be implemented quickly, and old legacy software, once it's been brought into NX layout, you can now clean out that old software forever. 2D components are what you create in NX layout. As you can see on the left, this example gives you the capability of developing a multi-level structure. And that structure is, as I've said before, the actual assembly structure that you're going to get as the end result of this. It is an extremely useful, effective approach, and it's a design-centric approach, but it's only 2D, and that keeps the concept a lot simpler. So if you do have AutoCAD users in the 2D world, they can get into NX and basically do the same thing and not get overwhelmed with the three-dimensional space that they've never really worked in. Usage of the NX reuse library is extremely easy to configure, and that's what saves your 2D components. Once you define a directory definition and customer defaults, you're ready to roll with it. It's easy, it's quick, and 2D components are really nothing that you haven't had experience with before. Once a 2D component is defined, it can be smashed down into sketch curves and their constraints, or a 2D component could be replaced with a different 2D component out of your reuse library. Or if you have multiple 2D components within your NX layout, any one of those could now be defined as a unique, different shape, size, location, orientation, etc., etc. It makes transference of other systems natural and unintimidating because this functionality isn't all that different at all. Do your companies experience a large overhead as a result of having multiple processes, such as multiple releases and notifications of the release, the documentation that goes out that specifies the product structure, the definition of part manufacturing? Are there related printing costs? Do you have workflow processes that have to be modified per project or per product? That's all overhead. It doesn't make you any money. If you're working in a team center environment where your data is all managed and it's accessible out of one database, NX layout is perfect for this environment. Do you maybe work with downstream disciplines, CAM applications, analysis programs, exporting to maybe outside resources, customers or vendors? They often can use these 2D profiles, whereas in a three-dimensional feature-based .prt format, maybe they can't use that. Now, our next slide is we're going to get into a demonstration here, and this demonstration will show you quickly how NX layout can be used. This obviously has already been started. We're going to make some modifications to this reciprocating saw, and as you'll see here, there is an obvious ease of making the changes to the design. Moving the reciprocating parts, changing the focus of exactly what component we might want to work on. Visibility is edited easily, quickly. Customization can be done with pop-ups on the screen. And again, with the 2D synchronous technology, curves in the 2D profiles can be edited very, very easily, and it's a lot simpler than the three-dimensional world because you have no z-axis to worry about. You have the ability to precisely define your sizes and locations. They can be dragged, or you can type in numbers and get them down to the 10,000th of an inch. You can locate your components to exact snap point locations, constraining the curves just as you do in sketching. It's very easy, very fast to move a component or change a component. It's just sketching. You can even, as we'll see shortly here, get into considerations for electrical components. We're going to finish up a little bit of an edit over here in the end of this bushing area, shorten that down, and then change focus, make a different component active. And as you can see, this particular component is actually a sub-assembly. It's the trigger assembly that controls, obviously, the amount of electrical applied to the motor. And this whole assembly can be moved around or edited individually. We can move that arc center down to a reference line. Now that becomes a pivot point, and we can just quickly drag the orientation of our trigger and get it ergonomically suitable. Once we're editing these geometries, we can match it, add in more geometries, conform to other patterns, other existing geometries, and you can see also it's not limited to just mechanical applications. We can add in representation for our wiring, and because it's 2D, you don't have that ridiculous behavior of splines in a 3D world trying to represent a thin wall of a wire. This battery assembly, as you can see, now being active, we're going to add on the casing. The casing is going to mimic or identify locations off of the existing housing geometry. And again, with sketching, it's very easy to create this profile of the casing. There aren't any Boolean operations to worry about right here, again, because it's 2D. And when you're updating your assembly structure, all of the visible listing over on the left in the resource bar there can be edited out of that resource library or in this navigator here, the part navigator. As you can see, all of this is part of that sketch that is named reciprocating layout. So there's really just one sketch on the drawing sheet. There are other applications, but in summary, NX Layout is a very easy to use 2D tool. It's fully integrated. What you can use there in that layout can easily be generating three-dimensional parts. As you tell it to go ahead and create the assembly, every one of those 2D components gets created as an individual part file and contains those curves. You can now use those curves and sweep them, revolve them, and create your solid features out of them. You can still go back to your NX layout and edit the profiles there, which would then obviously update the geometries in the individual piece parts. Elise, do we have any questions that may have popped up during that demonstration?
We do have a couple questions. Actually, from a local customer here in Missouri, was asking where it is in NX. Is it in NX 9?
Actually, it was created in and released in NX 9.0.1, not in the base release, but the first QRM after that. It has been obviously enhanced and modified in both NX 10 and a little bit more in NX 11. It is a product that really is custom tested. It's been developed out of, as I said before, the 2D synchronous. So a lot of any glitches or problems within processes have either been resolved or other methods and functionality has been provided to eliminate those little bottlenecks or whatever. Anything else?
Okay, yeah, we actually have another question a little bit west of us. Is there an alternative to standard modeling, or can you do both in the same part file?
Yeah, good question. That demonstration didn't quite get into it. It did show the ease of creating the 2D profiles, but if I were to quickly go over to an NX session and show you in a drafting part file that has just simply a drawing, as we look at the part navigator here, no model, no geometry created yet. In finding where NX layout is, it is the layout tab in the ribbon bar, and that contains all the tools. As you go to create geometry, you can add on a simple drawing view to work within the drawing view, and you can add as many drawing views as you want onto your drawing sheet, but then you'll make that the active view. And as you make that the active view or active sketch view, then you're going to see that it can be immediately and what would you say, automatically updated as soon as you create curves within that generation. So we're going to get out of the projected view, make this the active sketch view, and just show you a quick rectangle. Maybe if I was making a side view of a mold, as I go to create a rectangle, immediately the active sketch view enhances in size. As I go to make another rectangle, I can still find my alignment positions, and maybe this would be cavity and core side, or maybe these are the main plate and the ejector plate, or whatever, all contained within this view. Now, if I want to go to create 2D components, I can create a new one, or I can define an existing one. As I define an existing 2D component, then I'll be able to give it a name, an identifier, and a number of other things. So if I were to just call this plate-EJ, Then I could go ahead and select individual curves, and we'll just keep things very simple here. The constraint dimensions become a part of that 2D component, and now when we expand this drawing view and see the sketch, we now have plate EJ in there. Making another one very quickly here. Picking all four of the lines and calling this plate main. And again, when I say OK, it's going to notify me that it's adding any constraints of those curves into that 2D component, and now you can see both of those. Again, a simple and fast example here. When I say create assembly, it is now saying what do you want to call it, and I can choose whatever I want, what parts I want to use in there. So as I'm using my mold layout definition, and I've selected my part, I can identify layouts that I want, and if I'm looking at this layout, choose OK, and it now generates component objects, ties them together within model space, and now as I look at my trimetric view, you can see plate EJ, plate main, and of course I could simply extrude and pick one of these profiles. Yeah, if I don't have feature curves. I have to be working on the part, of course. Notice the structure. Now I extrude, just like regular assembly modeling. As I now go to create an extrusion from that, I might want to make that symmetric and maybe that large. So there's a quick example of how you can create your actual parts in your assembly. All right, let's move on. Did you have something to say, Elise?
No, I was just going to say that you were going to cover more about the realizing shape, and we had one more question here. Can you use 3D solids and NX layout?
As a matter of fact, you can, and I'll just show you very quickly once again that there's a button in the layout tab, and of course when I created the assembly there, it went into modeling. So if I go back into drafting, it brings back the NX layout, and when I go to the layout tab, you see that there is create from 3D. So if you actually have solids built in a part file, it can generate 2D profiles in an NX layout from that. Okay. All right, Realize Shape. Now, Realize Shape is really another conceptual design tool that, as you are generating new products, it allows you to identify and create with really a completely different approach, more of a morphing of an initial primitive type shape. And as we are developing this, it for the most part, it relates more to the industries that need to incorporate considerations for hydraulics or pneumatics or aesthetics, freeform type shapes, things like that. Not necessarily limited to that, but definitely an environment that makes this extremely effective in its result. You eliminate a lot of the problems when you're dealing with freeform features of continuity. And the result of this approach is going to be allowing you to get your product as a better product, and you're going to be a smarter developer, a smarter designer, and it will be faster to get that product out into the engineering organization over into production. Now, it's going to also allow you to solve a lot of the problems as you go from this traditional style of creating, again, freeform shapes. You start with the part file that's going to have some kind of curves in it, splines in it, extrude them, use them as guides or section strings. Multiple tasks can then allow you to do Boolean operations of adding or subtracting them. And then also as an alternate method of editing when you need to make slight tweaks to the locations or sizes or whatever, synchronous modeling comes in very handily. Now, with this approach of realized shape, it's a completely different approach. It allows an advanced freeform shape creation, but it's really not freeform as much as free shaped. Little slight difference in the terminology there. Now, I'll say that NX Realized Shape is intuitive and easy many times as I go through this, but we're going to see that it is a completely different style of approach. It allows you to create, as you can see in the list there, smooth, sharp transitions, sometimes referred to as washouts. And in this kind of technology, the surfacing methods are extremely innovative, and they get away from the traditional methods. And the bottom line here is that the continuity of the shapes will be high quality B surfaces. And many of the downstream applications and other software products recognize that directly without any need of translation. In the NX Realized Shape, it's basically a free shape creation method. It was introduced in NX 9. It's been enhanced in 10 and 11. It does support these new levels of advanced surface creation, integration, speed, it's all there. NX Realized Shape is more like forming with your hands what's imagined in the mind. Start with a primitive shape, and then push, pull, and reshape, reform, develop symmetry. You'll see that there are a lot of tools, and in essence, if you're familiar with the functionality of NX on surfaces, such as Xform, that essentially allows you to manage and edit polar vertices within a shape or of a surface, this is like a three-dimensional Xform. And it allows you to morph. That's kind of the trendy buzzword that they use with this. But these divisions of the polar vertices are referred to as cages. And the cage faces can be subdivided as much as desired to localize and give greater control. It's very easy to create smooth transitions in Realized Shape because it is essentially a single surface definition. There are a lot of options for shape creation. You have lots of options for your starting shape, but that one critical point that I made, that it is a high quality B surface, and it's an editable NX feature. So you create it as a feature, and then you can go on and you can add on regular NX features, such as holes and bosses and a plane that divides it or is tangent to it with a sketch on it, swept and united, etc., etc. It's reusable geometry, not redundant geometry. A little bit more here about being able to add in the other features that you're already familiar with. You have symmetric capability, and also you have in-context shape analysis and visualization that you can get into your high-quality shading. You can put appliques and surfacing, texturing onto them. That's not really any real different definition of exact analytic geometry. It's a very powerful tool for concept and industrial design. Now we're going to see the feature again is an editable feature, fully associative, so you can come back to it later and again modify, tweak, subdivide, add in small, more intricate details to the body. It is a B surface body, and as it shows, all modeling functions all work seamlessly on the resulting body. Now in that little example we've got there, we're going to actually show you a demonstration here of the creating of a shape very similar to that. It'll be slightly different here, but it's going to go very, very fast, and you'll see that it is a completely different approach of building CAD geometry. Now with Realized Shape, hey, it's intuitive and easy to use. Heard that before? You'll find it's almost as much fun as it is work when you're using Realized Shape. Here we started with a sphere, elongated it to a tube, narrowed down one end of it, and as I said before, you have many different kind of primitive shapes to work with. You just find the one that's most conducive or similar to the resulting shape that you want. As we get to the end of this, you'll see that the sphere really has very little to do with it, but yet it can still be morphed into the resulting shape. We develop wings, we develop symmetry with a simple switch that toggles on symmetric definition, make changes to one side, it changes the other side. Now if you're a little bit more technically oriented. The primitives that are used here in Realize Shape, they aren't the same as the old primitives that have been in Unigraphics and NX for so many decades. These actually start as what we call level 0 subdivision surfaces. And again, many of them as starting shapes, they don't have to be freeform. You could start with a block shape and keep the resulting Realize Shape body as an analytic, square, sharp corners, whatever you need. Here we develop a little cockpit design and subdivide things so that we can have a little windshield area. And you can see how quickly this goes. Admittedly, again, the animation here is sped up just a little bit. It's not that fast, but you can get a feel for just how productive you can be and how effective you could be in finishing off either entire product or just one individual part. And with this approach, you can see also adding in from a library existing Realize Shape parts, subcomponents. They can be added in, and again, as you add in blends, very, very easy to do. And the continuity of those surfaces, again, high quality B surface and very, very machinable, very usable with downstream applications. There you go. There's your futuristic rocket ship. Very quickly done. Ask yourself, what kind of options or opportunities would you have for something like this? Again, think outside the box. You don't necessarily need to always do it the way you've done it. You're probably going to find, if you did a good investigation, that you would have areas of your product, regardless of your industry, where you could create using Realize Shape. Typical industries, automotive, and you can see through any of these that are listed, some of them do have a dependency on shapes that conform to aerodynamics or to water and hydro applications, but medical, orthopedic applications, just hundreds and hundreds of possible uses for Realize Shape. Is it right for you? Well, you'd have to ask yourself, again, some more questions there. And as we would go through this list, as I said before, guarantee you that you'd be able to find some areas of the development of your products where Realize Shape could come in handy. And again, with that full integration, you're not going to be dealing with a different modeling or software program that then has to be brought into, imported, or translated for use in NX. It is an NX feature. Ask yourself some of these questions, and again, you'll find that maybe you do have some room in your processes to incorporate this. Adding it into your software, it comes as either a la carte or it can be part of a bundle. If you've got a Mach 3, that can be included in there. So you have really very adaptable accommodations. It's faster, it's easier when you're doing the industrial designs as you're creating these kind of shapes that have ergonomic considerations. Extremely easy. You can incorporate the symmetries, and as you are developing and using this more and more, you again can take advantage of libraries of existing parts that again could have iterations, add on detail features, form features, modify shapes, sizes, locations. It's all there. And it's all, as you said, integrated within NX seamlessly. Elise, any questions so far on Realize Shape?
We actually have a question that I think references your first topic. They wanted to know, once the 2D components have been sent into assembly structure, can they be saved as reusable part files?
Yeah, sure. Keep in mind that what I showed you there in that quick little mold example, as I created one NX layout and then defined two individual 2D components, an ejector plate and a main plate, sending them, so to speak, or creating the assembly from that actually created the individual part files. And when I went and worked on one of those part files and then extruded the profile of that 2D component, that solid body was then a child feature of what the NX layout had generated. Now, if I had some parts that were already 3D in design, and as I said before, or as we showed you before, there is a function to bring in the 3D definition as a cross-sectional profile in an NX layout. So it can actually go in both directions. Anything else?
On this realize shape section, we had a question. What do you mean when you say high quality B surface?
Okay. Many of you in the audience probably have familiarity with the fact that NX is a NURBS-based modeling system. It is a non-uniform rational B surface. And that means that the surface in the curve definition is, it has a mathematical definition that involves all of the kind of characteristics that you might want in the various industries, particularly automotive, where you may want Class A surfacing. The B surface is created by realized shape. They're not going to have aggravating discontinuities and peaks and splits between them, or just mathematical errors, tiny objects, things like that. This is high quality. It eliminates all of those possible problems. You don't have to use NX examine geometry or optimize surface on any of the realized shape definition. Anything else?
Nope, that's all I have for this section.
All right, I have one other quick little illustration of the newest entry into concept design from Siemens. This is convergent modeling. And convergent modeling, it seems to follow suit, and this is where I kind of step aside from my loyalty to the mothership as a VAR or as a partner here. It seems like Siemens likes to come out with new innovative terminologies, new phraseologies. It makes their product stand out. They appear to be innovative, cutting edge. Convergent modeling, whatever you want to call it, this is a really cool thing. What it's doing is combining the two worlds of CAD modeling to that of the graphics world and that of scanning. You can bring in STL or stereolithography data into NX and actually use it in solid modeling. So it ties together the conceptual phases of the graphics area of product development into the engineering area where CAD is being used. And again, it's going to be seamless integration, and you're not dealing with multiple software products. It's all part of one workflow path. Now, as you're importing STL data into NX now, you have three options for the facet body type. An NX facet body, which again has been around for decades. JT, which by the way, that Jupiter tessellation format was actually developed by Siemens. And now we have convergent. And convergent means it is able to be usable by analytic or exact CAD geometry. That dialog for import also, as you can see, includes some other options where you can get information about the actual importing process and control how accurately or how much you wanted to break it down in the tessellation of that surface definition by the minimum facet number. Now here's all the different feature and functions in NX that can work with convergent data or convergent body geometry. And I'm not going to go through all of them, but you can see there is a lot of NX. I couldn't really tell you if that's most of NX or what percentage of it, but you can see it crosses applications as well. Not just modeling, but wireframe, curve definition. You can use it with reverse engineering. You can also get into analysis with measuring, obviously. It has measurable points and angles, surface definition, curvature, etc. And finally, you also have the ability to use it in assemblies, maybe making a product outline. And this is going to be, again, generated from scan data coming off of other physical objects that you may have gotten from a vendor or a customer. Not only modeling commands, but analysis, wireframe, and assemblies. And this really expands the mind of those that are into concept design. As you're dealing with convergent objects, there are some limitations. When you are working with exact analytic CAD geometry and modifying or adding in additional shape to that, the convergent body definition is persistent. It lets you know that whatever your result is will be a product that is convergent in its definition. And analytic is the terminology that they refer to as the exact CAD, what we're normally used to, the traditional model as we've been building them. And the note there, you cannot export convergent bodies to other applications or to non-NX files. And a good example of that is if you were to simply import a .stl file, call it a convergent body, and then go to drafting. No, drafting will not allow you to add views of a convergent body onto a drawing sheet. That's where the line is drawn. There are indicators, by the way, that Siemens plans to develop this even more. Now I'm going to do, again, a quick illustration here of convergent modeling. And here I have a part, and I'm going to go back to modeling. Currently in drafting from that NX layout, so we are in modeling, and this is nothing more than a block with some blends on the edges here, and I'm going to go up and import an STL file. So import, and if you're familiar with importing, there are many different formats. Choose STL, and we're going to browse to the right location. Make sure we get the file that we want to bring in, a .stl file, and I have other settings there that I can also play with, but we'll just get it going. Now, with that definition, if we go back to the import dialog window for STL and drop that down, you see that was an NX definition. That's a facet body, not convergent. And that's the big difference. You need to work with convergent definition. As I put my cursor over that, you'll see that it does say it's a facet body. A little bit different definition. So we're going to undo, import again, and change that definition for the facet body type to convergent. Choose OK. It's going to be the same part file. It remembers that. And now it has to do a little translation. You notice how this one's taking a little bit more time. It's bringing it into the same area where my block is. And just to show you, as I hide the block, there is the actual body that was brought in from the STL file. And we bring the block back. Now I'm just going to show you that it's usable to modify geometry. If I do a simple subtract command and I pick my block as my target body, I can now use the convergent body as a tool, and it gives me a pop-up here that says, as we discussed already, the output will be a convergent body because input is analytic as well as faceted. An extract body feature will also get created. It's extracting a body from the convergent body and then using the extract body to actually create the subtracted cavity in my block. The other thing that's actually going to be doing here, because of the shape of that convergent body, it's actually splitting my block into two different bodies. Not a problem. It's going to be able to create the cavity in between them and still maintain shapes off of the convergent body surface. It's interesting to note that is indeed one surface, a tessellated surface of the convergent body. And as you were to go to other commands, you would find that selecting the surface is going to select all of it because, again, it is all one surface. There are many commands that can be used to convert that body into a facet body if you brought it in as convergent, and other options that you can trim them, split them, etc., etc. Now, again, I'm going to just blank out the outside part here, and you'll be able to see the conforming shape of my block. That's the analytic CAD geometry, now reshaped, redefined, modified by the convergent body. Now, there's a lot of industries that can use this, and again, this is one of those areas where you in the audience may have some areas that you've always done it one way, you've always used another software product. Now you need to start rethinking things and get outside of the box. Can you consider doing this? Those industries might include medical, dental, just repairing broken molds, a mold, whether it be a vacuum form mold, injection mold, blow mold, whatever. Sometimes they get crashed and there is no original definition, no drawing. You just have to digitize it and then try and build a new one off of what you digitize. Well, here's where you can bring in that geometry and use the exact geometry that you want. This is unprecedented in product lifestyle management. It bridges the gap between the aesthetic graphic world of concept design and engineering CAD design. Any questions here?
We do. Can a convergent body be used as a component in an assembly?
It certainly can. Yeah, it can actually be, as if we were to go back to the listing of all the features, you can link a convergent body into another part file. So therefore, if you created an assembly and you had one component in that assembly that you had imported an STL file as a convergent body, you could then link that body into another component within that assembly and use the linked body to, again, either create new geometry, modify, trim, subtract, maybe tooling could be created off of the convergent body that's linked into your tooling part. So yes.
Okay. Actually, we have another one. Can this can this geometry be exported to a 3D printer?
Yes, that's exactly what it came from, essentially, is the format .stl. And we're seeing a lot of advancement in 3D printing nowadays. In fact, we've just ventured into another, we at Swoosh have ventured into another business of 3D printing. And yeah, we could export the definition out of what I created in that example there. And although I forgot how exactly big that is, it's a huge tub. It may be bigger than our table in our printers that we have here. But yes, it can be printed in 3D directly out of NX.
Okay, wonderful. Actually, that's all the questions we have. So thanks so much, Garrett, for doing our presentation.
You're welcome. Thank you, folks.
We are out of time, but if you do actually have any further questions about today's session, please feel free to reach out to us by phone or email. And if you're already in contact with one of our representatives, please feel free to reach out to them too. Either way, we will be here to help meet your business goals and better production experience. Watch out for your email. We'll send you guys a replay video. Also on our website, you will be able to see the tutorial that we did today, and our YouTube channel, you will also just be able to see that as well. Once again, thank you guys so much for joining us today. We hope that you enjoyed our session and hope that you can make it to our next session. Our next session is actually covering Scratching the Surface is the name. It's going to be on December 6th at 2 p.m. Central Time. If you haven't registered yet, visit the URL that is shown on your screen.